Question 1 explains about bubble sort. Students must understand that bubble sort repeatedly compares adjacent values and swaps them if they are in the wrong order. The largest value gradually moves to the end after each pass. Question 2 is about bubble sort passes. Students should carefully trace the list after each pass and observe how values move step by step. Question 3 asks about the total number of bubble sort passes. Students should remember that for n items, the maximum number of passes is n-1. Question 4 explains insertion sort. Students must understand that insertion sort inserts each value into the correct position inside the sorted section. Question 5 asks students to perform one pass of insertion sort. Students should identify where the current value should be inserted and shift larger values to the right. Question 6 explains the merge step in merge sort. Students should compare values from two sorted lists and combine them into one sorted list. Question 7 asks about the time complexity of merge sort. Students should remember that merge sort uses divide and conquer and has complexity O of n log n. Question 8 explains linear search. Students should understand that linear search checks each item one by one until the target is found. Question 9 asks students to perform a linear search where the value is not found. Students should count all comparisons carefully because every item is checked. Question 10 compares linear search and binary search. Students should remember that binary search requires sorted data. Question 11 explains binary search when the value is found. Students should follow the middle values checked during the search process. Question 12 explains binary search when the value is not found. Students should understand how the search area becomes smaller after each comparison. Question 13 asks students to perform the first pass of bubble sort. Students should compare adjacent values carefully and swap them step by step. Question 14 asks about the number of bubble sort passes. Students should apply the formula n-1. Question 15 explains how insertion sort builds a sorted list gradually. Students should insert each value into its correct position. Question 16 explains a complete merge sort example. Students should observe how the list is divided, sorted, and merged back together. Question 17 explains finding the position of a value using linear search. Students should check each value from left to right until the target is found. Question 18 explains the steps used in binary search. Students should carefully follow the middle values checked during the search. Question 19 explains bubble sort on an already sorted list. Students should understand that no swaps are needed because the list is already in order. Question 20 explains the final step of insertion sort. Students should continue inserting values until the entire list becomes sorted. Question 21 asks about the first step in merge sort. Students should remember that merge sort first divides the list into halves. Question 22 explains binary search positions. Students should track how the search area changes after each comparison. Question 23 compares linear search and binary search. Students should understand that binary search is usually faster for large sorted lists. Question 24 asks about the time complexity of merge sort. Students should remember that merge sort has complexity O of n log n.